Thank you for coming, and sorry for being late. I had an allergia at the beginning of the afternoon, and I had to go back to my hotel, and when I came back, I was a little off schedule. I wanted to talk about DevOps, but not about tooling, and I chose to talk about something that requires tool, but it's more about the process, and the question we can answer to help applications work fine. So monitoring is all about data, and well, I like finding information when I have some monitoring data, and I hope I want to share with you all this love for data, and I hope at the end of this session you will like doing monitoring and like having a lot of data. So I want to share with you some motivations to do some monitoring, to collect data, but also to provide data. Because the monitoring system can get information, but if you don't produce your own information, there's nothing to collect. And I'll also explain some user stories and the best practices, the practices that are behind. I don't know if they are the best practices. And I'll explain you how to get started, because I hope Monday you will want to do monitoring, and I want you to have some hints and some starting point to do that. So before I go on, I would like to know who you are, and I will be able to take my breaks because I ran up to here. So this is a DevOps and methodology track. So I would like to know who is Dev. Raise your hand if you're a Dev. Okay, a lot of people. Who is Ops? Okay, who has been up for more than 2 years? Okay. And who is neither Dev or Ops, but more on the methodology side or the project side? Okay, mostly Devs. So my name is Claude Falguiere. I'm a DevOps coach and trainer at Valtech Paris. So I'm a consultant. I've been working for 20 years or so, mostly in Java, mostly in architecture and performance tuning. I'm also involved in some organizations, especially Devoxx4Kids, where I'm the coordinator for France. And there's a session at 7, and the people that do this, there's a lot of people that work with me that do wonderful sessions with kids, and it's really interesting. Please come to this session. I'm also in some other organization, but I will skip this. I have a blog at this address, and I uploaded the slides to SlideShare for people that want to read the slide from their tablet or computer, so they're on the blog. So monitoring is about questions, and often you find out that you need monitoring when there's something happened, the application crashed or something like that. And there's a lot of things you would have had to log before. So one of these questions is, how do you know that the database, what do you do when the database is broken? And how do you know it? What do you do? These are user stories that you can have. What do you do if the number of hits doubles every 2 months? This is typically a capacity planning problem. What do you do if you know that users struggle to find, I don't know, the order form? So these are user experience problems. There are other problems you might also have to solve. Why is that app is slow? Why user? What are the kind of products users want to buy that are more business-oriented questions? So behind monitoring, I put technical monitoring, but also all the information we want to gather from an application. And this is because tools used to be different. Each silo has different tools. But with BA technique and big data tools, they all tend to use the same kind of products. So first, we have questions, we have hypotheses, and we need facts. And on the other hand, we have a lot of data. And in the middle, there are models. So we all have models. If we think that, I don't know, users will be more inclined to buy if products are cheaper, it's because we have economists have designing this kind of model, and we consider that it's a valuable model. If you think that the number of replies should be equal to the number of requests, this is because you have an implicit model that each time a request enters, it must go out of the system. So there are a lot of models we implicitly use. And I want to explain something about models and how models are built. So there's a problem that's been around for a few centuries that is named galaxy rotation problem. It's not in computers, but it's about data. And in physics, they can't jump into a spaceship and go take samples of the stars. They have to use data. They have to use observations from telescopes and try to understand from there. So the problem is the galaxy, here the image is fixed, but actually it spins around the center, and it's spin too fast according to the model. So I will not go into details, and if you want more details, you can go to Wikipedia and have other explanations. What is interesting is how they discovered dark matter. That is one of the more exciting things in physics. Actually, at the beginning, they just considered that the data were wrong. So this inconsistency between the estimated mass and the estimated speed and what they observed, just think the data were wrong. Because the telescopes were poor. But after we had better telescopes, and now we were sure that we see all the objects that were visible and the data are true. Then the question, is the model wrong? Because the other way to match the data and the model is to consider that the model is wrong. But they had strong evidence that the model is true because it applies here, it applies in other parts of the universe. So some people think about the problem, and then they say, okay, the data is true, the model is true, but we're missing something. There's something we don't understand in the relation between the data and this model. So later, Vera Rubin had Nobel Prize because she found evidence and she found another way to estimate the mass that doesn't create this gap. And later on, a few years ago, Planck satellite was launched and he validated this hypothesis. So when we build a model, when we build hypotheses about how the system works, we always have this kind of path. Sometimes you will feel that data is wrong, sometimes you will feel that your model is wrong, and sometimes you will discover new things. For instance, if sometimes there are gaps between what you can observe from the client side and what you measure from the server side. And you might have the same path. Okay, maybe and it's more critical if this measurement is done by two different companies or services, because people will fight, you're wrong, you're wrong. But actually, they might be right on both sides. But for instance, if you have queues, the client will measure the time between the time it sends the request, the duration between the time it sends the request and the end of the response. But the server will just measure the time that is required to serve the request and will not take into account the time the request was in waiting line until it could be handed on. So this is the kind of things we have to take care when we do measurements. So this year, the Measure Everything movement has populated data. And there are many reasons. Measure everything, first, what it means. I struggle a lot in France because when I say measure everything, people say, okay, I want to measure everything and I will be drawn it by numbers. But actually, this is not the idea. The idea is when you have to make a decision, you need facts to make your decision. And then you need more information and you need to gather data. And more often, you need to have anticipated and collected data you will need later to make your decisions later. So one of the movements that is linked with this is Lean Startup. Lean Startup is a sort of methodology that say, okay, don't use a big design up front, but try building something small, and then learn, check what happened, and learn something from this system. And when you learn something, you will have new ideas to improve the system. So this is basically the idea. It's the idea behind a lot of iterative methodology. And the other thing that produces a lot of data is DevOps. For many reasons. First, because it brings a lot of tools to monitor more easily than before. And the other reason is if there are two contention points with apps. The first one is when you deploy, because often it doesn't deploy so easily. The second contention point is when something fails, something crashes, something is too slow. And the apps have a lot of monitoring for the system and network layers, and they just expect you to have the same kind of monitoring for your applications. But often this is not the case, because we did a lot of user stories for all what the customer wants, but no one think of the user story for apps, or the user story you need as a developer to be able to improve the system. And the other change is big data. Well, what does it mean, big data, for you? Well, for a lot of people, it means Big Brother, something that watch you. But for people that do data science, it has a slightly different meaning. First, it means more volumes. Up to big data, we have to select carefully which metric we want to use. Big data opens the door, and we are now able to store a large amount of data. And the other part is artificial intelligence techniques are now available, and they provide new tools to analyze data, to do some classifications, use machine learning algorithm. And the way we build models has changed. Before, the models were designed by humans, and they think of the data that should feed this model to produce new facts. With artificial intelligence, there's a little change, because the model will be built by the machine learning tool. So it may discover new things we didn't think about, because we are too logical, and the system will just check what happened. And the computers are really good at finding patterns, finding cycles, finding relationships within things, even if it looks crazy. So this is again a list of questions. These questions, they fall in 5 categories, but covered by 2 kinds of tools. So the first one is SLA. Each time you have a commitment, a service level agreement, people will want to measure if they fulfill their commitment. So this is a kind of monitoring that is usually in place because someone needs it, and usually the apps need it to be able to assert that they fulfill their commitment. And in addition to that, there are alerts that are raised when the commitment is not fulfilled, or when something may prevent the commitment to be fulfilled. So this kind of tools is named alerting tool, and these tools are tools like Nagios, JMX, or this kind of tools that your ops presumably have. The other type of monitoring is more based on tools that collect data, they store that, and they give way to visualize the data and make charts and so on, and make an analysis on top of the data. So the first category is diagnosis. If you want to understand why you doesn't fulfill, why is there a problem, you have to have data that explain why things are going wrong. Especially, you have to have data that are still available when the process is not there. The second category is capacity planning. You want to be able to say if you will have enough capacity next week, next month, next year. And the last one is improvement. This is linked to lean startup. If you want to improve things, you need metrics, not only to have foresight and to troubleshoot, but to measure where you can improve things. So there are a lot of components, and people are sometimes lost between all these components, and when they try to understand how they work all together. So first, on the right, monitoring is mainly, and alerting platforms are mainly used by people, level 1 support people. So they will check the alerting system and receive messages by different means, SMS, mails, and so on. And they will dispatch a message depending on what the problem seems to be. On the other side, on the left side, there's an application that usually has two means to send information, to provide information to the monitoring, logs and probes, sort of a component you plug into your application to provide data. So this is presumably things you know. The last part is all the systems that are in the middle. So there are a lot of different solutions, but they all end up to this kind of schema. So you have tools that are dedicated to parse log, and some others that can collect data. So they know a lot of formats, a lot of probes, and they know how to get data. And often they provide you with a list of metrics for different systems. And they all put data in storage, and this tool often do some aggregation of data. They can, for instance, if you collect metrics every second or every minute, with time they will compact the data and just keep an average on hour, day, and so on. And they also provide visualization tools. So basically, the collector has, most of the collectors are sort of frameworks where you can put plugins or activate plugins, depending on what you want to do. So you may have plugins as input. You may have plugins for system, app servers, database. Some of them, they also know how to parse logs, and they also know how to get data from other collectors or other storage systems. And as output, they can store data, send data to an alerting platform, or put them in a queue. Usually, you will have some log parser or collectors close from your application that gathers the data, and then they send them to the monitoring platform that will store everything. This is a more resilient topology, because when you are in this situation, if for any reason the storage cannot respond, you will lose your data. So often you will find queues just in the middle, because collector and log parsers will send data to a queue, and then the queue will send data or try to resend the message until it's okay. So what would you do if you knew that your database is broken? Actually, how do you do that? That your database, how do you know that your database is broken? Because you can't open the door and say, oh, see, the database is broken, or the database is on fire in this case. You have to collect data, you have to ask the database, put some check that try to place requests to the database and say, okay, it doesn't work. And most often these problems are collected by the client. The client will log, or when you try to access the database and get some error, cannot connect or something, you will place a log. This is what people do more usually, because log is an asynchronous system and it's very robust. But you might also send events. It's more complex because you have to know the format and the protocols that the receiver use. So what's really important in that case is context. Remember, the person that will get the alert is a first level support. And this person, we have to make a decision about what the criticity of this error, and what kind of error is it, who is responsible for that, is there an impact, should I warn the client, should I stop the system? So you must provide a lot of information in order that it can do its job. So is this a log? Well, I have one of my colleagues say, when you write code, you should write code like if the guy that will take over is a psychopath and know your address. Well, at 3 in the morning, the guy that reads that is not that far from a psychopath. There's no information in this, no time, no severity. You know, sometimes there's a time in front and the severity, but I think you all know these logs, because this is due to the default in most of the IDE. When they propose a catch, they just print stack trace, and most of the developers, they just let the print stack trace. So logs are full of these very long messages, and sometimes there are 100 or 200 lines, and there is no information. I went up to the bottom, and it's a main loop that call a generic action, that call a generic service, that call a generic repository. So there's no way to understand which function is having a problem. So this is a more clever log, so you have to adapt it according to your needs. But the things that are really, really important is timestamp, severity, a context. The 4 last lines is a functional context, which service, or you may want to log which function, but don't log the function from the code perspective, because it's often meaningful. But you need to understand what will be impacted by the error. Maybe an ID. So it's always interesting to have an ID, because you may have other support that is reporting a problem with a specific order or action. You may have other systems that report errors because of errors in this system. A technical context, so for instance, the name of the instance and the number of the thread that is often provided in a log, and a meaningful message. So who should decide if the message is meaningful? So, sorry? Yeah, the support guy, because he will have to understand what's happened when you get this log. So the first line is for the support guy, and you have to, well, from my point of view, it's okay, but you will have you up if it's okay. Sometimes the problem cannot be fixed by the first level, so this message will be sent to someone else. So you may also have to investigate on this problem. So you also need information for you, and you might need information for the DBA. This is a problem with the database, so you might need information that is that maybe has no meaning for you, but will explain something to the DBA. So is it okay? So to go into details on the kind of tools you can use to check the logs, there are situations where your logs are handled by the alerting system. Just be careful, because the alerting system is usually not designed to filter a huge amount of logs. So either you have logs that are very small, or you may, the right way to go is to use another option. And be careful, you must be very careful with the alerting system, because if there's no more alerting system, what happened? Like, if something fails, you won't know. So the alerting system should be very resilient. So the other options to parse logs, well, there are a lot of collectors, and each new language generated new collectors. So one that is very popular in Java is Logstash. Another one that is often used is Python, because Python is available on a lot of machines. And if you want to do some Hadoop, you can use Apache Flume, that is a system based on Hadoop. And so I mentioned Splunk because it's one of the references in the domain. So parsing a log is very simple with this kind of tools, because you will just say, okay, my input is in this directory, and my filter is this filter, and these tools provide filters for most of the common formats here for Apache. And if you want to parse your format, it's really easy to build a custom format with a sort of high-level regexp. So often the problem is also not one message. If you use an external service, you will have a lot of, or you may have a lot of timeouts, and it doesn't matter if it's only once. But what you want to check is what you want to raise an alert when there's a lot of these errors, because it's probably a problem. So here you will place an alert based on a threshold. If the number of these errors is over this value, I will raise an alert. But it might be really difficult to find the appropriate level, because if your activity has a cycle, the alert might be different at the beginning of the day and at the end of the day, for instance. So there are tools that do baselining. So typically baselining is a way to place the threshold not at a fixed value, but as a percentage of the usual value. You don't know what it is. It's like artificial intelligence, where the tool will detect a pattern and detect what is an usual value, and you will say, okay, I want to be alerted when it's 10% above or when it's 10% below. So being alerting very early, it's useful because it will give more time to fix a problem, and apps will be very happy. So second problem, what would you do if you knew that number of hits double every 2 months? I think you know. It will be prepared to resize your system within 2 months. So this kind of question will be answered by graphers or all the tools that are on top of the storage. So typically the kind of information you want is a distribution. For instance, do I have the same number of requests on all my nodes? That might be one of the questions. Do I have cycles? A lot of activities have cycles weekly, during the day, or on the year. Make correlations between different data series, or for instance, correlation between some resource that is used and the number of orders that are placed. And foresight. So here is a very simple case because the trend is very visible, but when a trend is mixed with cycles, it's less visible for human beings. So there are statistical techniques that help divide the impact, isolating the impact of the cycle and the impact of the trends, and make more useful predictions. So the tools that is really common, but tends to be replaced, is graphite. So graphite does the storage and also is a grapher and produce graphs like this one. So Graphos is an old school tool. So you will have a list of metrics, and then you click on the metric you want to display, and it displays a chart. Graphite doesn't have any mean to collect data, so we'll mix it with one of the collectors and send data through either through plain text requests or REST requests. But the need changed, and now there are a lot of people that collect data, and they tend to need the same data. So what would be great is that data is collected once in one of these systems and available for many persons. But then you need dashboard. You need different dashboards on your data. And dashboard is also a way to display information for people that are not very skilled for one of the systems. So when you do dashboards, there are different levels. So for instance, at the top, this might be a dashboard for support. Only big numbers, few information, and it's alerting. In the middle, it's a dashboard that is presumably designed for dev and ops, dev or ops. They want to have an overview on one page of all the metrics that are available and check correlation visually. And at the bottom, it's more something for the business. Do you see the main difference? It's white. It's white and with sections, and it more looks like a report with section, more information, more messages, nice 3D curves and so on. So the requirement for visualization now is to have dashboards, and it's also to be up to date. Because a few years ago, you ask for the apps that they send you data, they will send you a file with data. And now people want to have access to the information immediately to be able to fix a problem. And in general, it must be flexible. So all the products were created. So one of the popular stack is on the right, and especially in the Java community. So Logstash as a collector, Elasticsearch as a, what they say is not a database, but it's used as a database here. And Kibana. And Kibana is not typically a monitoring tool, but it's a BI tool. It's the main message. It's a BI tool, and it can do nice graphing. So some people made the same kind of product that's named Grafana that can work on top of Graphite, InfluxDB, and some other monitoring dedicated databases. So didn't talk about InfluxDB, so it's a new database. Well, Graphite is great, but it's difficult to scale because you have to do the distribution by yourself. Well, they provide tools, but you have to add additional tools to do the distribution. And Graphite is also a pain to install. There's a lot of Docker files that are provided, but well, it's not really easy to install. So Graphite is a fixed size database. It uses something that is called RRD. So when the data is old, it has less precision than when the data is new. InfluxDB is a new DB that is dedicated to metric. It's easy to scale, but it's new. It's less stable than Graphite. So these are three stacks, and well, they are open source, and all of them works fine. So you'll need to provide data to put in your storage, and this kind of data here will be durations or number of orders or data that you produce in your applications. And one of the ways to produce them is to use JMX. JMX stands for Java Monitoring Extension. It's part of the API, and it's implemented in your application server. And the application server provides its metrics through JMX. So if you want to write your mbin, it's straightforward. It's just a plain Java class with a getter. But it might be a little tricky to register the object. So some Netflix provided a library which name is Servo to help registering objects through annotations. Another issue with JMX is it's based on RMI, and RMI over firewalls is not, well, the RMI use random ports, so they have to open random ports on the firewall. So since Java 7, there are configurations that allow to fix the port on a specific number, and also to deal with the fact that the name on both sides of the net might be different. So it's easier to use than before. But another option is to use Jolokia that expose the JMX service as HTML. Or another option is also to have a local agent named JMX Trans that can write in different formats, generate plain text or write in different storage. There used to be a problem to collect data in Java, but now it's fixed, and you can have JMX collectors in Logstash, CollectD, and a lot of platforms. Well, I'm a little late, so I will skip that. And another popular option now is to send logs with REST. So one reason is JMX is not so easy to use, and the other is there are front-end tools for front-end applications that they use JavaScript, so they can't use JMX. So this way you have a common way to send data to the storage. And remember, the storage, they all know how to read REST requests, so you can directly store your data if you want. But usually this is not, usually the monitoring still goes through collectors, because the collectors can apply some rules, filter, drop data that are not interesting, and so on, add some new information. So what would you do if you knew that your application is slow? Well, this relates to tuning, and tuning requires a lot of data from a lot of different systems. And the main problem is you don't know all these systems. So it's often useful to have collectors or commercial tools that know how to monitor all these systems and get the interesting metrics. So what would you do if you know that the customer can't use the application? So this is a user experience issue. And there are tools that exist for a while that deal with web analytics, user tracking, and collect this data. So you may have used Google Analytics. Yeah. So the Google Analytics is an online service. Sometimes people don't want, companies don't want to use it because they don't want to give their data to Google. There's another tool that is open source, which name is Piwik, that's quite the same service, well, basic service, because there are things that are very complex in Google Analytics, and sometimes I don't understand. It's really for people that do marketing and are really experts in whatever analytics. But if your use cases are simple, you can use Piwik. And most of them have reporting API, because the issue is we collect data in their database. So if you want to use this data in your storage and be able to correlate data with what you collected from the system and the app server, it might be tricky. So what kind of information do they collect? You will have to provide information with different means. The first means is to use the page counters. So usually you just have to put some JavaScript in your web page, and this will automatically send the name of the page to the tool. If you have an AngularJS or other form of one-page application, it's not useful because the page will never change. So you may have to use tagging inside. And if you want to have very specific information, I want to know if the user hit this button or this one. I want to know what the user typed in the form. You can use tagging to get this information and send new information to the system. And this system, this kind of tools, they also know how to parse logs, parse web server logs, so they can get information from the URLs. So what would you do if you knew what users want to buy? This is typically all the big data systems that will do that. There still are things that you can do without a big data system. Someone told me that he set up a Hadoop cluster with hundreds of nodes to check the logs and found out which search phrase users use in the application. Well, actually, you can, when you build the application, it's really easy to log the search phrase or to get the search phrase from the GUI. So why would you analyze a lot of logs later? Well, you have to make decisions about where you get the kind of data are meaningful for you, and log this data in your application instead of trying to use very complex mechanism to get this data. But there are some situations where you didn't anticipate and you don't know how to do that, or some kind of analyses that are usually provided by this tool. If you want to do classification and recommendations, there are dedicated tools that will help you with that. And if you want to do some pattern recognition, it's the same. But don't feel that you will simply put all your logs in the machine learning tool and it's magical, you will find something. Actually, it's more complex than that. If you put a lot of logs in the machine learning tool, you will have to provide what you expect from this. You will have to train the machine learning tool first, before it can work, and you will have to provide the logs with what you expect from these logs, and maybe the machine learning tool will learn how to parse a log. But this is not usually what you want to do, because you know how to parse it, you know the format, you know it's really easy to do otherwise. So machine learning will be useful when you have parsed the logs and get information that makes sense, and they are sent to machine learning systems that will try to find more information from that, and correlations, and this information, sometimes you will find some hypotheses or some links you didn't see, and you might increase the number of requests, number of metrics that you collect explicitly from your system. So 6 minutes, okay, it's okay. So to get started, the first step when you start monitoring is to define what you want to do with your monitoring, what kind of question you are interested in, and the list of facts that you want to collect from your platform. And you set up monitoring and you will get fast, and for a while it will be okay, but sometimes you will have some gap or something that is weird and has questions. Then you will make a hypothesis and need new data and add new metrics. And this is a continuous improvement process. You will not find the ideal monitoring from scratch. So people often ask, what should I monitor? But actually it depends on your application. But there are categories. For the basic monitoring, being aware that something is wrong and basic troubleshooting. The things you have you monitor is the presence check. Is my website still responding? The activity, it's kind of sizing. How much do I have? How much users? How much requests? How much orders? Because it explains the metrics. Any resource that is limited in size, so physical resources, CPU, memory, bandwidth, storage, and so on, but also all the logical limitations in your applications, caches, queues, pools. These things are configured to accept only a certain number of requests or a certain number of something, and might cause your system to have to generate errors. So errors to be one when something is wrong, and others because it's when you are when something doesn't work, you will have to explain the other side that something is wrong. And it's always useful to have some measurement on each side. And even if it doesn't match the measurement of the other, it's not a fight. Well, I'm a fight without any fact and any data. Other things that you should monitor, it's all dependent on the kind of your application, but you may also often have issue with performances. So the system monitoring and the web app server monitoring, they give you a lot of metrics on how the platform works. But if you have a process that's going through a lot of steps, might be tricky for you to understand where you spend time. And if you go through many instances, for instance, it might be tricky to understand where you spend time. So it's always useful to log the time you spend in each of these steps. In a general manner, everything that is a large data set, everything that implies a lot of repetitions, iterations, and so on. User navigation, because when you want to check user experience, it's always useful. And for context, each time you want to log something, just think that if you log only 42, doesn't mean anything. You have to put context, a unit, where the measurement point, where did you get the data, which was the name of the metric, and which domain is impacted. So as a takeaway, I want you to learn from data. And there are two ways to learn from data: continuous improvement. Even Picasso couldn't draw a perfect bull in one step. He made a lot of sketches before he went to the final bull. And design for failure, we often believe that when the tests pass, everything will be okay and the system will run perfectly in production. But actually, this is not the case. The planes are tested, and everyone does its best to avoid plane crashes, but it happens. And they have flight recorders, and you must have your flight recorder, because if things can fail, they will fail. So, it's done. I will reply your questions if you have some. You have 2 minutes. Okay, no questions? Well, I think you can go. There's a break now, so have a good break. Thank you.